Are we in an AI hype bubble? Welcome to the Talk to Me PDD podcast. I'm your host, PDD. This is my podcast where I discuss people management, leadership, knowledge work, and more. Today's topic, AI. This is episode 29, the AI hype bubble. So it's been interesting following the news. We've seen pretty much all of the major CEOs and leadership in companies doing significant generative AI and large language model work suggests that we are in a hype bubble right now. Starting to show up a little bit more kind of in major media and some other areas, but really surprisingly to me anyway, not as much as I might have expected, given the people leading those efforts are making that claim. So it's really interesting, and I think it's something to keep an eye on and to watch out for. It does feel like that's the case. And now that begs the question, what does it mean to be in a hype bubble? It doesn't mean that there's no value to this technology. It just means that some of the areas that it's being expected to do things probably aren't going to happen, and maybe not all of these businesses will survive, or maybe not in the way that people are anticipating them to. So you look, for those of us that lived through the internet hype bubble, pets.com, not around anymore, but still, massive value and economics, productivity provided by the internet. So potentially a good area to compare it to. You've also more recently have things like the metaverse, which was a bit of a bust, but there still are some use cases and value that came out of that, and potentially more developmental that'll happen in the future. So two sort of extreme ends of different bubbles there, some with a small amount of utility and some with a large amount, but still, when those bubbles burst, a lot of the companies in tech and innovation tended to die, and some things survived. But so I think it's also important to note that this hype bubble, while we say the AI hype bubble, it's really referring to generative AI and specifically large language models. There's lots of different AI and machine learning that I think will continue on and has been in development and in use for some time that is sort of outside of the scope of this particular hype bubble. So I'm going to look at four different areas that might suggest or do suggest that we are in a hype bubble, and kind of go into detail there and explain sort of what I've heard and my thoughts on those different areas. So the first one being that generative AI and large language models do not appear to be profitable for the companies that are running them, that are hosting the data center infrastructure to run large language models and inference and train the models. It's not clear that these companies are generating a profit now. It seems like they're losing money. OpenAI has this multi-year plan to profitability, but there's going to be billions of dollars in losses in the meantime to get there. So at a certain point, there's a sustainability issue there. And is there a market where customers are going to be able to pay enough to make these services profitable? And one of the challenges there is it's very difficult, as I understand it, to accurately price generative AI services based off large language models, because you don't necessarily know how much compute you're going to need from a user. So if you're trying to bill per usage, even with that model, you may not know in advance how much things are going to cost and how quickly costs will go up. If you're trying to do sort of an all-you-can-eat approach, which a lot of the services have now, some users could easily blow up your profitability. So it's complex as well as costly. Now, I wrote a little bit about this, and there's plenty of other sources about it, but it's important to understand at least a little bit about the infrastructure that runs large language models. So the data centers that are hosting large language models are not general purpose. They're not the same type of thing that, Azure or AWS traditionally would host a website or other services like that. And they can't easily be switched over to serve, standard workloads like those that, there's always going to be demand for. So the hardware and the way these data centers are constructed for generative AI is really single use. All of these large language models are running on specialized GPUs, so graphic processing units, not in the same way that some other GPUs could be used for different applications, even for gaming, but other data science type work or image rendering or that sort of things. The GPUs used for large language models are really specialized, and this is the only purpose that they're relevant for. Those data centers are also wired differently from a power perspective. The amount of power needed to run these data centers is extremely high. But also from a networking perspective, these are distributed systems, meaning that it's not just one computer that can serve the model, answer questions. You need to combine many different servers running many different GPUs together, and they can talk to each other over a network. And there are some specific requirements on how that networking infrastructure is built in the data center that doesn't apply to general purpose data centers. So there are some very specific differences, and you can't use one for the other necessarily. Now, there's some arguments with any new technology that costs will come down over time. And then that may be true in some cases with some of the models that have been around a little bit. They may be more efficient at serving them. But one of the things that I've seen spoken about and written about is that as we're getting into newer, more advanced models with reasoning, things like that, that even though sort of for an individual token might be cheaper, you need to send many more tokens in an interaction. So the costs are actually potentially going up. So there doesn't necessarily seem like there's a path where costs will come down with usage over time or as models advance. Training these models is very expensive. If they continue to get larger and larger, that's only going to get more and more expensive. Specifically to ChatGPT, an interesting one, and Ed Zitron did a great piece on this, is that in their newest release, they have sort of a routing infrastructure in ChatGPT itself. So it's deciding what model to send you to behind the scenes instead of letting you pick. And on the surface, that seems like, well, that'll be more efficient because you can pick a simpler model in a lot of cases, and maybe you're only using really expensive reasoning models when you need to. And it's kind of getting into the weeds, but an interesting thing that he exposed about that is that then you can no longer cache some of the information in the query that you used to be able to. So even though you're potentially gaining some efficiency on choosing more efficient models, anything that you've made up there, you've lost because you can no longer cache a part of the query, the prompt that you were sending, which then introduces more costs. So it's unclear, at least right now, whether that is actually saving costs. It might be adding more. Maybe in the future they find a way to do it more efficiently and do some of that caching. But that's something specifically to ChatGPT, not the models themselves. So what do we do about this? If it's not profitable to run these large language models, at least at scale, maybe there's a shift to using smaller language models, and those can run either on the edge, like on your own PC or phone, something Cal Newport talked about in a recent podcast. Not so much around the financial costs, but more around sort of how to mitigate the environmental costs of current large language models. So, that seems like a great solution if that happens, or even if you're combining multiple specialized language models together with some other infrastructure, and being able to run it on your own machine or even on commodity hardware in the cloud. But if that's the solution, then what do you do with all this AI data center specific infrastructure that has already been built and seems like planned to build much, much more? I think you'll probably see frontier models continue to be trained there, and maybe some other specialized uses. But if there's no path to profitability with AI specific data centers, it seems like that's going to be a problem for the industry. And the only really way that you can find a path forward is a way to leverage that infrastructure and serve these models profitably there, which it's not clear that that is possible. So that's the first challenge, probably the biggest one. I think that if it's not profitable to serve these models, there's only so long some of the current trends can continue taking these losses. The second one is the scaling laws, or the idea of the scaling laws and whether they'll continue. So if you're not familiar with this, this is the idea that when you're training these large language models, you put more and more data and more compute into the models, and they're going to get exponentially better as you do this. And that held true for many of the earlier models across many different companies. And a lot of the predictions about sort of how capable or quote unquote intelligent these models would be was based on these scaling laws continuing, at least for some time into the future. Now, I'm not going to say it's consensus that these laws are no longer holding, but many people are starting to discuss that now, that we're not seeing the same types of returns on increasing data and increasing compute in these models. So some of the speculation about how capable generative AI would be was based on those laws. And if those laws are no longer holding true, some of the capabilities that experts thought we would have are not going to be here, or at least not in the same timeline. An interesting term that I've heard thrown around is that, the AI systems that we have today, speaking about generative AI, are going to be the worst AI systems that we ever work with. And that may be true, but I would also say kind of a caveat to that is some of that I think is based on the scaling laws, that these improvements, exponential improvements, were just going to continue. But also, even without that, that may not be the case. So an interesting idea that I came across recently, these large language models are trained on massive amounts of data. A lot of it comes from the internet. Now that they've been around for a few years, a lot of the data on the internet is now generative AI generated content. So future models built on the internet are now not necessarily consuming human generated content, but they're consuming human generated content consumed with significant amounts of language model generated content, which probably isn't providing the same type of information quality that was there before. So even by increasing the amount of data, if the quality is going down, because large language models are generating so much, we may actually get into a situation where model quality is getting worse, even though we're consuming more content and language models have been around for some time. Not saying that's going to happen necessarily, but I think it's something interesting to consider when we're looking at all of this. Also, with most technologies, you get this idea of low-hanging fruit, where you do solve a lot of these easy problems in the beginning. You get a lot of gains, a lot of bang for your buck. And then as things mature, you have diminishing returns. You have to put in significant more effort for significantly less return. A good comparison to the scaling laws is Moore's law, which people may be familiar with, the idea of how computing power is going to increase along a particular slope over time. And that has held true for quite some time, but will come to an end at some point. It was always predicted to, as you get to sort of the physical limits of what you can fit on a chip. But another thing is that the cost for that law to continue wasn't constant over time. I was reading recently that to continue making these increases in Moore's law with the speed of computer chips is now it's something like 18 times the investment to get the same type of return that was there early on. So this happens in a lot of technologies, so it's not surprising that the scaling laws may be falling off, that things may get harder to make gains. So any predictions based on that exponential curve holding may not be true. So that's the second one. Whether the scaling laws will continue to hold, whether we'll get some of the improvements that people expected with generative AI. The third one is hallucination, and the problem, bug, or feature there continuing and being a difficult challenge to solve. So hallucination being the term for when generative AI models tell you something or give you an answer that is false. And because large language models don't actually understand any of the data, they are purely prediction machines. This is a feature of these models, and in my opinion, something that's not likely to go away when we're using this same type of um, algorithm and data structure to serve generative AI. Um, One of the things that I thought was interesting, and this comes from Ed Zitron, is he expanded the definition of hallucination to not just be a false response, but also to be things like a misunderstanding of user intent, or in things like software development, going and doing things that don't make sense, or saying you did something that you didn't do. So hallucinations apply not just in giving an answer that's not factually true, but in a variety of other aspects of what large language models may do. Um, and I really don't see a way around it. OpenAI came out with a paper recently where they were um, suggesting that because of how their models were incentivized to take tests, and where, like many standardized tests, guessing is rewarded as opposed to saying you don't know, because you're not penalized on the test for saying you don't know. But if you guess, potentially you'll get the answer. Um, so the hypothesis of that, or the thesis of that paper, was that if we incentivize these models not to guess when we don't know, you could mitigate some of that hallucination. And maybe that's true. We'll have to see. That would drastically change the performance of these models on the tests that they take and the benchmarks for their progress. Um, but because they are just prediction systems, it's built into how they work. And at least from my perspective, it seems impossible that you'll be able to totally eliminate it, which means you're never going to get a totally predictable system, which isn't desirable in a lot of cases, and especially a lot of the cases that early on generative AI proponents predicted would be things that these systems would do. All right. Last aspect of the bubble here, number 4, automation. So this was something that the capability curve and the scaling laws sort of naturally led to, that these systems would become more and more capable. Think quotes like they'll be able to do any sort of economic task that people can do, or have the equivalent of a PhD student in terms of intelligence and capabilities. So there was this idea that AI was going to take over a lot of the work that people were doing, to be able to fully automate tasks at the beginning of 2025. This was supposed to be the year of AI agents, and thinking about AI agents really as equivalent to human workers, at least aspirationally. Um, and that really hasn't come to fruition yet, in many situations. And really, what I've seen AI agents become is more about traditional automation. And this was a quote that I came across in an AI agent training that I was taking recently, and I think it's apt that AI agents are really more about the automation part than the AI part. And automation is incredibly valuable. I mean, even before the rise of generative AI, I think there was many opportunities to add automation into business workflows, and I think it can be win-win for both knowledge workers and for customers, being able to take particular tasks or parts of that that are strictly defined and just making them happen, and making them happen quickly. But effective process automation based on kind of defined inputs and outputs is very different than sort of human level intelligence operating independently and doing tasks, which was sort of what this year started off on selling AI agents. Um, I mean, you can do it. One of the terms that comes to mind, and this came up in the book Power and Progress, which I read recently, and this was not their term, but reference from someone else. I can't remember, but this concept of so automation, where you can take humans out of the loop with automation, but you're getting a worse experience. It's effective in a sense that it accomplishes a task, but it's not as good for the customer or the consumer as having a human there. And obviously, it's not good for the human workers who no longer have that work. Um, so now we're in the situation where you have to decide if you want an AI agent or AI automation in your workflow. Is it worth it to have sort of the ease of use of natural language processing and sort of the natural conversation with generative AI systems? But the trade-off being you're going to have some unpredictability. You're going to have to provide a lot of context to narrow that down, and there's going to be some additional costs. So it's a trade-off on whether that's worth it or not. Now, I do think one of the benefits of generative AI has provided us is to sort of bring back to light the value of automation, of having really good knowledge management systems, of having some structure around your data to leverage it. So I think there are a lot of benefits of it. But at least so far, 2025, the year of AI agents, hasn't necessarily materialized exactly as how some predicted it. So to sum it all up, some of the signs that are pointing to the fact that we are in a bit of an AI hype bubble now. Not clear that it's profitable to run these large language models. Not clear that the scaling laws will continue and that some of the capabilities that were predicted will ever happen. Hallucinations and the unpredictable nature of large language models are an intrinsic feature of these models. They're not going away. And AI agents are more about automation than AI. So there you go. Food for thought. Maybe you agree, maybe you disagree. Interesting times as always. We'll see what happens. Thanks for listening or watching to this episode of Talk to Me, PDD.